activation energy. We saw the graphs for endothermic and exothermic reactions. Most reactions, even exothermic reactions, require something to start them. The magnesium ribbon does not burn when held in air, nor does the firewood. We need to ignite the reactants for the chemical reaction to begin. The minimum energy needed to be absorbed by the reactants in order to start a chemical reaction is called the activation energy. It is denoted by EA. In the case of magnesium ribbon, heating the ribbon for a few seconds gave it the required energy. Let us explore this further. When we mix the reactants, the molecules of the reactants are constantly colliding with each other. Hundreds of such collisions occur every second. All these collisions are ineffective because the reactant molecules lack sufficient kinetic energy. For collisions to be effective, there must be a minimum kinetic energy that breaks the bonds between the atoms of the reactant molecules. The kinetic energy of the molecules can be increased by increasing the temperature. By igniting the reactants with a flame, we provide the required kinetic energy to the molecules, which move faster. The resulting collisions kickstart the reaction by breaking the bonds in the reactant molecules. Between the time that the bonds are broken and new bonds are formed, an activated complex is formed. The activated complex is a transition phase that lasts for a very short period of time. In the complex, bonds in reactions are breaking, while new bonds are forming. The energy level of this activated complex is higher than that of both the reactants and products. The temporary activated complex then gives rise to product molecules. The energy graph that we sketched earlier can be modified to include the activation energy. From the graph, we can say that the activation energy is the difference between the chemical potential energy of the activated complex and the energy of the reactants. For an endothermic reaction, the activation energy is usually much higher. The activation energy of an endothermic reaction is depicted here.
Starting to feel it? Now go master it with Askmaski.